Alright, today we're going to have a lesson on same-side interior angles and parallel lines. Let's start with the definition. Same-side interior angles are two angles that are between two parallel lines and on the same side of the transversal. An example is, we have two parallel lines, we have a transversal, but we're looking at the angles that are on the same side. For example, angle 3 and angle 5 are same side interior angles because they're between the two parallel lines. And notice that angle 4 and angle 6 are also same side interior angles. Right, the theorem for this is that same side interior angles have a sum of 180 degrees. So the relationship between angle 3 and angle 5 is that their measurements must add up to 180 degrees. And likewise, angle 4 and angle 6, they must have a sum of 180 degrees. Let's apply this to some problems. All right, let's say we have two parallel lines and a transversal. I have two pairs of same side interior angles. So I have angle 5 in this angle. So I know that measurement of angle 5 plus 75 degrees must equal 180. If I want to know that measure, I have to subtract 75 to both sides. So the measurement of angle 5 must be 105. And in a similar way, if I want to know the measure of angle 6, I know that these two angles are same side interior. So measurement of angle 6 plus 105 must equal 180. So if I subtract 105 to both sides, I get that measurement of angle 6 must be 75 degrees. Alright, so let's look at the problem. We have two parallel lines and a transversal. And we want to know the measure of angle 3, 4, and 5. Alright, looking from the past definitions, we know that we have a situation with vertical angles. So I know that measurement of angle 4 must equal 85 degrees, just based on the definition of vertical angles. So if this is 85 degrees, according to what we just talked about, these have to add up to 180, 85 and 95. If that does, you know it's correct. But we have two other same side interior angles. That's angle 3 and angle 5. But going back from previous theorems, I know that measurement angle 5 must equal 85 because it's alternate interior to angle 4. So, and I know that angle 5 and angle 3 have a sum of 180. So if I know angle 5 is 85 degrees, measurement of angle 3 is just simply 180 minus 85. which means measurement angle 3 must be 95 degrees. Alright, here's another situation where we have two parallel lines and a transversal. And we want to know the value of x as well as the measure of angle 2, 3, and 5. Well, to find the value of x, we know that this is a situation of vertical angles. So I can say 2x plus 1 equals 71. And when I solve that, I get that x is 35. And notice that 71 degrees and 109 add up to 180 because it has to satisfy the definition of same side interior angles. Angle 5 must equal 71 degrees because alternate interior angles are congruent. So angle 3 is simply 180 minus 71. Which means that measurement of angle 3 has to be 109. But notice that angle 3 is alternate interior to this angle, which also forces it to be 109. Alright, this concludes my lesson for today.